Welcome back, students. In this video we'll be doing exercise 1.2, the first two questions. But before we proceed, there are certain concepts that you'll have to understand in order to do exercise 1.3. The first thing is what exactly is, we'll be coming across many terms like rational, irrational, primes, co-primes. I hope by now you're already familiar with what a prime number is. So when I talk about co-primes, okay, we talk about numbers whose common factor, okay, whose common factor is 1 alone, is simply 1. Okay, these are numbers, okay, numbers whose common factor is 1. All right. So when I say so for example 2 and 3 is a co-prime because the common factor between 2 and 3 is 1 alone, right? Yes, 1 is both a multiple of 2 and 3 itself. Now even when I talk about 4 and 9, pay close attention to it. 4 and 9 are not prime numbers. You agree? Because 4 is actually a composite number because it's a multiple of not just 1 and itself but also of 2. Same goes for 9. It's a multiple of 1 itself as well as 3. So it's not a prime number, but this is a co-prime because 4 and 9 have a common factor which is 1. 1 is a multiple of 4. 1 is also a multiple of 9. That's the only common factor that 4 and 9 shares, right? For example 5, 9, 11. You just focus on these three numbers. Obviously 5 and 11 are prime numbers. 9 is not a prime number. However, these are all co-primes because the common factor between all these numbers is 1. It could be in the case of this 2, 9 and let's just say 20, okay, 25. Okay, you look at all these numbers. Obviously, these are all numbers which are also co-prime because the common factor is 1. All right, mind you, 9 and 25 is not prime numbers. However, the common factor is 1. So such type of numbers are called co-primes. Okay, so next time, whenever I say that 2 numbers are co-prime or 3 numbers are co-prime, then you should get numbers like this in your head. That means the common factor that they share is 1. Okay, all right. Now, second thing that you actually need to understand is called rational numbers. All right, so rational numbers are all those numbers that actually exist in this form, p by q, and p and q are integers. Okay, so in order to understand this, let's try to dissect this. What exactly is an integer? It's usually represented by a capital Z or a Z in bold letter. Okay, so these are numbers like 0, plus, minus 1, plus, minus 2, right? I hope you're already familiar with this in your class 9. This have been repeated many times. So these are integers, okay, usually in this form. Remember, 0.1 is not an integer, neither is 3 by 2 an integer. Clear? You understand? Now, rational numbers are of this form, p by q form, where p and q must be integers. So this p also must be one of these numbers. Only one of these numbers. It cannot be any other number. Q should also be one of these numbers, right? So let's see what are rational numbers. Is 2 a rational number? Yes, 2 is a rational number because even if it's not written, it's understood that 2 actually means 2 by 1. So this is in the form of p by q. Next thing, let's just see, is 2 an integer? So it tells us that p and q are integers, right? So p in the case of this is 2 and q is 1. So is p an integer? Yes. 2 is an integer? Yes. Is 1 an integer? Yes. Are you clear with this? Same thing, let's go with 3 by 5, okay? So is 3 by 5 a rational number? Yes, it's a rational number because it's in the form of p by q. Is p, now let's go, p refers to 3 and q refers to 5. Is 3 a rational number? Is 3 an integer? Yes. Okay, 3 is an integer. Is 5 an integer? 5 is an integer. Okay, all right, integer. Okay, now some of you may be thinking 0.1 must not be an integer, right? Because 0.1 basically means 0.1 by 1. Yes, so 0.1 is not an integer. However, what we understand is 0.1 can actually be written as 1 by 10. So whichever values you can rewrite them, you're actually supposed to rewrite them. So 0.1 can be written as 1 by 10. You agree, right? So now 1 becomes an integer, 10 also becomes an integer. So 0.1 is also an integer. It's also a rational number, okay, because 0.1 can be written in this form. Is everyone clear with this? Now, what is an irrational number? That means Irrational number is actually those numbers which are of this form, okay, you can say of this form, but p does not belong to an integer, p or q, okay, this will not belong to an integer. So suppose I say, okay, root 3, obviously root 3 by 1, all right, but let's see, is root 3 an integer? Is root 3 an integer? See, integers are just plus minus 3, not plus minus root 3. So is root 3 an integer? No. So that means this given root 3 is an irrational number, because it may be in the form of p by q, but it's an irrational number because either your p is not an integer or your q is not an integer. Clear? So even numbers like 1 by root 2, okay, is this an integer? Is this a rational number? This is not a rational number, it's an irrational number because p, here look at this, p is an integer, right? P is an integer. You look at this, okay, see, p is an integer, but q is not an integer, is not an integer, hence 1 by root 2 again is an irrational number, okay. So in irrational number, remember, it can be of this form, all right, but here in the case of this, either p is going to be it's not going to be an integer, or q, all right. You can come across both times like this, root 3 by root 2, that this clearly is an irrational number, only by fold, okay, or both, you can write this, okay. So either p is going to be, it's not going to be an integer, or q is not going to be an integer, or you may even come across certain numbers where both are not integers, okay. So you just try to remember this string. Co-prime means factors whose common factor is 1. Rational number means it is of this form where both p and q are integers, and irrational numbers means it's usually of this form, but p is not going to be an integer, or q is not going to be an integer, or both is not going to be an integer, okay. So quickly moving on, we'll move with this, okay. We have to prove that root 5 is an irrational. So what I'll do here, okay, not solution, we'll go with proof, okay. So I'll take the contrary, okay. We assume, okay, we're assuming that root 5 is rational. So what happened is a rational number. So if root 5 is rational, so root 5 must be in the form p by q, right? Yes, rational is usually in the form where p and q are both integers. Remember this statement, okay, are both integers. Much more than remembering, try to understand what rational numbers are. So I'll just take this root 5 into q equal to p. I'll just take here, okay, I'm just taking this to the left hand side. So squaring both sides, we square both sides, 5q the whole thing square equal to p the whole thing square. So we get this as 5q square equal to p square, okay. That means p square is divisible by 5, okay, 5. Then p is also divisible by 5, all right. You look, 5 into something is equal to p square. So this is like me saying that 30, okay, 5 into 6 is equal to 30, okay. You look at this, I'm just assuming, okay, let's just say I'm just assuming this to be my p square and this to be my q square, okay. I'm just saying, okay, clear. So p square is divisible by 5, so 30 is divisible by 5, yes or not, okay. Same thing, p is also divisible by 5. That means if you take square root, okay, that's not the best explanation, but it's quite difficult to come up with an example, okay, but I hope you're understanding, okay. 5 into something is equal to p square, okay. Next, therefore, if p is divisible by 5, so what do you understand by p divisible by 5? It's understood that p is equal to 5 into, I'll assume this to be my PQR, okay. Divisible by 5 means it can be written as something like that. So see, 4 is divisible by 2. By 2, it means 4 can be written as 2 into okay, but if, okay, clear, 4 is divisible. Now 4, see, just listen to the statement. 4 is divisible by 2 means 4 can be written as 2 into 2, okay, or in the sense, okay, or it also means this 4 divides 2, okay, you can always write this, all right, 2 divides, and this all right, so 4 is divisible by 2. And then next is, if 2 divides 4 means, 2 divides 4 means it will be 4 divides 2, okay, it's something like this, okay, just listen to the, just be clear. When I talk about divisible, that means p is divisible by 5 means p can be written as 5 to something. So I'll take the square root of that, okay. So what do you have for p? P is equal to 5 into r. So I'll replace p equal to 5 into r in equation 1, okay. So you'll be getting this as 5q square, and p we're getting it as 5r, okay, so 5r square, so 5r the whole thing square. So you get this as 5q square equal to 25r square. Now q square is equal to 5r square. So what does this mean? This also means that q square is divisible by, it's divisible by 5, and q is also divisible by 5, all right, divisible by 5. However, okay, so both q and p are divisible by 5, okay, but we forgot to take this, but you should write here, we assume with 5 in p, these are rational numbers, okay, and you have to write p and q are co-primes, okay, co-primes, all right, you have to assume that. Now both are divisible by 5, but p and q are co-primes, okay, which means the only common factor between p and q must be 1, must be 1. So this is a contradiction, this is a contradiction, right, it's a contradiction to our assumption, what was our assumption? Assumption that, okay, that root 5 is rational, hence, so since we are getting a contradiction, we got a contradiction because we took the assumption that root 5 is irrational. So since it's a contradiction, so root 5 must be an irrational number, okay, irrational number, clear, all right. Next question, we have to prove that 3 plus 2 root 5 is irrational. We prove this with the same concept, okay. So let us assume, okay, we'll assume that 3 plus 2 root 5 is rational, okay, is rational, all right, okay. Therefore 3 plus 2 root 5 must be equal to, I'll just take this as a by b, where, or let's stick with p by q, okay, since we're starting with this p, where p and q are both are integers, okay, are integers, all right. So I'll be taking, what I'll do is I'll take 2 root 5 and I'll take 3 to the other side, so p by q minus 5 minus 3, right. So take whatever is necessary, p minus 3q by q, and you take root 5 equal to p minus 3q by, these 2 will go down, so this becomes 2q. Now since p and q are integers, okay, hence p minus 3q by 2q is a rational number, okay. You just take an example. You see p minus 3q by 2q. So what we have written, p and q are integers, right? So you do one thing, you work it out on your own. Okay, clear? This is a homework you'll have to think. Okay, I'll not be explaining this as to why. I'll just give you a hint, not exactly an, okay. So p and q are integers, so you substitute p and q as some integers. Okay, any integers, you just put p. If p is 1, you put q as 2. Okay, if p is equal to 1, you put q as 2, because remember, q and p are integers, so you can just substitute any value you want. If you put p as 0, you put q as minus 1. If you get p as 10, you can put q as minus 30, and you just substitute different integers, and you see, okay, and you see the whatever value you get for this, it will definitely be an integer, because you may get, suppose if I put p equal to 1, right, I'll put 1, and I'm going to put q equal to 2, so 3 into 2, and q is again 2, right? So I'll be getting this 1 minus 6 by 4. So it's going to be minus 5 by 4. Now you look at this. This is a rational number. Why? Because minus 5 is an integer, yes, and also 4 is an integer. So it's in the p by q form, where both p is an integer and q is an integer. Okay. So for every substitution that you do for p and q, as long as p and q are integers, this is going to be an integer by default. Okay. So you look at this here, root 5 is equal to p minus 3q. Let me write this again. Root 5 is equal to p minus 3q by 2q. Now you look at this. So since we already got that p minus 3q by root q is an integer, is a rational number, we must also, that means root 5 must also be an integer. Okay, be an integer, must be a rational number. Yes, it must be a rational number, because root 5 is equal to p minus 3q by 2q. So p minus 3q by 2q is a rational number. That means root 5 is also a rational number. But we know, okay, we know that root 5 is not a rational number. That root 5 is not a rational number. All right. You see, root 5 is not a rational number. How do we know this? You take root 5 by 1, okay, it's understood. If there's nothing, but it's still understood. So p by q form, for any number to be a rational number, p must be an integer, q must also be an integer, but p is not an integer, right? Q is an integer, because 1 is an integer, but root 5 is not an integer. So root 5 is not a rational number. Okay, hence our assumption is wrong. Our assumption is wrong. Okay, it's wrong, or there is a contradiction to our assumption that 3 plus 2 root 5 is rational. Our assumption that 3 plus 2 root 5 is wrong. Therefore we say that 3 plus 2 root 5 is irrational. Okay, is irrational. Okay, clear? Alright, so with this we will end the video here, and we'll do the next remaining questions in the next video.